So we're looking for the perimeter of the square. So like I said before, if we're looking at a circle, we always start with the radius, right? And that is given to us. So let's go ahead and make a dot, make our radius, and that's going to be 8. Now I can choose to go this way horizontally and make a right angle. But then we also know in a square, perpendicular diagonals do happen. So it says the radius is 8. And I need to find the perimeter of the square. So I need to find what this side is right here. This side over here. So let's do our ratio. Is this 45, 45, 90 or 30, 60, 90? 45. Very good. So we have x over 8. Now x is opposite of the hypotenuse or opposite of the right angle. So what number do I need? Radical 2. What number do I need next to the 8? 1. And then we cross multiply. So we get x equals 8 radical 2. To find the perimeter of the square, the perimeter is going to be 4 times my side. So if I do 4 times that, it's 4 times 8 radical 2. And the whole numbers can be simplified together. So how many is 4 times 8? 32 radical 2, and we're looking at centimeters. Any questions on this one? Good? Okay. For number 2, Kinsey, let's read. So they gave us the area, and we also have equilateral triangle, so we can use the side square root 3 over 4. Always start with the formula. Area is equal to side square root 3 over 4. And what I know right now, do I know my S or do I know my A? We know the A, so I'm going to plug it on the left side. So we have 12 radical 3 is equal to side square root 3 over 4. And something unique is on the left and the right that is identical. What can I cross off?
Radical 3.
Radical 3, very good. So if I rewrite this, I'm going to write the variable on the left first. Side squared over 4 is equal to 12. How would I get rid of divided by 4? Multiply. So we're using algebra. So multiply by 4. That goes away. So I now have side squared. It's going to give us 48. And I know I want simplified radical form. So when I square root this, let's think about how we're going to break this apart. What 2 numbers that includes a perfect square could go into 48? 16 times what? 3? So we know 16 is a perfect square of who? 4 radical 3. And that's going to be in meters, yes. All right, for number 3, Ethan, let's read.
Find the side of a square equal to the area to a rhombus with the diagonals 8 centimeters and 14 centimeters.
So we know rhombus has diagonals 8 and 14. If you look at your formula chart, perpendicular diagonal formula is on there, yes? And the perpendicular diagonal formula says area is equal to diagonal what? 1 times diagonal 2 divided by 2. So if I were to plug them in, we get area is equal to, my diagonals are 8 and 14 divided by 2. Let's do this in one go. What is 14 divided by 2? What is 7 times 8? So we know the area is 56. And now they're asking us, what about a side of the square? So we know our square area is side squared. What I know right now, is this 56 for the S or the A?
The A.
It's for the A, so I'm going to plug that in. So we have 56 is equal to side squared. And again, we're simplifying the radical, which is fine. So I'm going to write that off to the side. You can divide it by 2, but I think it could also be divided by 4. What 2 numbers would create that? Radical 4 and? Did someone say 14? 14? Very good. And for 14, if I further break down 14, we get 7 times 2, and then we're stuck, right?
Yeah.
So we're looking at square root of 4 is perfect square of who? 2. And then we have remaining radical 14, and we're looking at centimeters. Does number 4 look very, very familiar? We saw quite a bit of it.
Yeah.
So if we're looking for the area of the shaded region, we take big circle minus the what?
Little circle.
Little circle. So let's go ahead and elaborate on here. We have our big circle with a radius of something minus a little circle with a radius of something. We know our little circle at the center to the side is 10. Oh, I don't know why I made that circle so tiny. If this is 6 over here, it is also 6 over here. That means our big circle has radius of 16. And then it says the area, so we're going to use pi r squared twice. So we have, for the first one, we have pi 16 squared minus pi 10 squared. Now we know 10 squared is very comfortable, 100 pi. Anybody have 16 squared memorized? It ends with a 6. That's what I can give you. Oh, that would be too much. 2. Very good. 256. Is it okay that it's not memorized?
Yeah.
Can you do your like elementary math this thingamabob? Yes, you can. Now they both have pi. Can I combine them?
Yes.
So we know our remaining must be 156 pi meters squared. So number 5 is the one that we had to use a calculator because look at this ugly decimal. On our test, I'm not going to give you ugly decimal like this, okay? It'll be doable without a calculator. But just for the practice sake of the process, let's actually work on this together also. Brian, let's read.
Which one?
5.
The regular hexagon is shown below. If one plot is approximately equal to 0.3048 meters, find the area of the shaded region in square centimeters to the nearest 10.
So this was kind of mean. I gave you the meter unit, and then I want the centimeters. So I have to convert it how many times? Twice. So we know 1 foot is about 0.3048 meters. So let's go ahead and write on here. On the calculator, type in 16 times 0.3048. And I want to keep all the decimal. So we're looking at 4 point how many? 8768. That's for the meters. The next conversion I did not give to you because if I go from meters to centimeter, how many decimal places do I move over? Because if you think about century, it's 100 years, right?
Yeah.
So if I move that 1, 2, that's going to give me 487.68 centimeters. Now we can do the math. So before actually jumping to conclusion, are we finding all of the area of the hexagon? We're finding 1/3, right? 1/3. And if you're like, I can't see it, go ahead and separate it like this. We have 1, 2, 3, 4, 5, 6. And because we have 6 equilateral triangles, can I use sine square root 3 over 2? Yes, I can. But what I'm going to do is double that, sine squared root 3 over 4. And we're using a calculator on this one, so that's kind of nice. 2 times, my side is 487.68 squared root 3 over 4. Exactly as you see. Let's all type it in together. Root 3, close, oh no, go down, 4. Okay, somebody confirm what you have on your calc is what I have on mine. Good? It's gonna be really big, right? Because if I square that 400 something, it'll be a big, big number. So we know the area for this one is going to be 205,968.3654 feet squared. That should be everybody's bank account, right?
It's feet, not centimeters.
Is it feet or not centimeters? Oh, you got me. Centimeter squared, very good.